Welcome. Today we are working on adding and subtracting radical expressions. To be able to do that, we first have to be really good at simplifying. So, how do we simplify this? We've got 2 times the square root of 3 times 4. But 4 we can write as 2 squared, right? We're going to look for the perfect squares. Here's the perfect square. We take the square root of that out of the radical. Now we have 2 times 2. Radical, what's left inside is 3. And we can simplify that to be 4 root 3. Good? Let's try this one. This is the same thing as, let me go back to green pen. This is 3 times root 40. Simple way to split that is 4 times 10. This is a perfect square. I don't have to simplify that one anymore. 10 is not primes. It either has to be perfect square or primes. So let's take the 10 out, and we'll write 10 as 2 times 5. Okay, looking for perfect squares now. Found one right here. That's a perfect square. We take the square root of it out. Now we have 3 times 2 on the outside. And on the inside, we still have 2 times 5, which is 10, of course. So here we go. We have 6 root, whoops, sorry. That should have been a 5. 2 times 5, 6 root 10. Okay, moving along. If we are going to add and subtract radicals, think of it this way. Here's something that might look familiar to you. If you have 2x plus 3x, what do you have? Well, this is the same thing as x plus x, right? Plus, now 3 more x's, x plus x plus x. We have 5 x's. Think of radicals the same way. We've got 3 root 2. That's root 2 plus root 2 plus root 2. Now I have 4 more root 2's. Plus root 2 plus root 2 plus root 2 plus root 2. Altogether, that makes 7 root 2. Easy? Good. I'm going to skip this one because it's basically the same and go on to subtraction. Let's say I start with 7 root 5's. Root 5 plus root 5 plus root 5. Boy, this gets tedious, doesn't it? The good news is you don't actually have to show all these steps. This is just a visual representation to teach you the concept, but it's going to be really easy just to skip straight to the answer without going through all this. So I've got 1, 2, 3, 4, 5, 6, 7 root 5's. Let's switch to a different pen for the negatives. We're going to have negative root 5. How many of them? We've got 3 of them. Minus root 5. Do you see some 0 pairs? 0 pair. 0 pair. Root 5 minus root 5 is 0. Answer is, I've got 4 root 5. Easy? Good. Let's try this example down here. What's different here, you'll notice, is we've got some square root of a's, and we've got some square root 3's, right? So we'll start with purple. Actually, let me start with red. Let's write out all of our root a's here. No, I'm going to start with green. Sorry. Okay, so I've got 6 root a's. Root a. I'm not going to add the plus signs this time because I'm quickly going going to run out of room. This is a big problem. Okay, I've got 6 root a's. Now look, I'm going to put the negative 9 root a's next to the positive root a's. We'll use blue for those. So we've got, how many do I need? 9 of these. Minus root a, 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 minus root a. 3 more, minus root a, minus root a, minus root a. Do you see that I have minus 3 root a's? What can I do with the root 3's? Those are completely different. They are something completely different. You have to do those on a different side. We've got root 3 plus another root 3, right? And now we're going to take away, let's do black for negative. We're going to take away a root 3. Okay? Here's 1 0 pair there. These are 6 0 pairs here. Answer. I've got negative 3 root a plus root 3. Do you think you could have done this without doing the visual representation? Could you have done 6 root a minus 9 root a is negative 3 root a, and then 2 root 3 minus root 3 is just root 3. There's an invisible 1 there. Okay. Last question here. This one, trick question. Y's and root y's are not the same thing. Okay? Those are not like terms. There is, if I did a visual representation, I would have 10 y's and then I would have negative 2. You'd have to do it on another side because they're totally different. We'd have negative root y and negative root y. And the answer would be 10y minus 2 root y. Nothing would change at all. Okay. So, simplified radical expressions are like terms. Okay? So, looking at this, we are going to highlight the terms above that are in the same, highlight the like terms above in the same color. All the root 5's are like terms. Positive and negative still like terms. All the root 7's are like terms. Okay? Tell you what we'll do. Let me grab this exact equation and we'll put it over here. This should be on your worksheet. Let's see how we solve this. Let me highlight this up again. There we go. Here and here. Now let's solve it. Let's start with the blue terms. 3 root 7 plus 6 root 7, that's 9 root 7. Easy. Let's do the purple terms. I don't have a purple pen, so we'll use green. 12 root 5 minus 8 root 5 is 4 root 5. 12 minus 8 is 4. Answer. Done. Let's try another one. Okay? Let's do all the root x's first. Here, and the negative root x here. Okay, 8 root x minus root x, there's an invisible 1 here. That makes 7 root x. And now, let's do the root y's. And that's going to end up being negative 10 root y plus 6 root y is negative 4 root y. Okay? Simplify. Can we simplify this? Are they like terms? No. But watch this trick. I notice that this is not a prime. And it's not a perfect square either. This can be simplified. We have to at least check. I can rewrite root 8 as root 2 times 2 times 2. Do you see a perfect square? I hope so. Perfect square is right here. Take the square root of the perfect square out. You end up with 2 root 2. Now we're going to plug that back in here. Okay? So this becomes 2 root 2 plus 2 root 2. Answer, very easy, 4 root 2. Okay, moving on. What happens if you have a problem that looks like this? Whoops. What happens if you have a problem that looks like this right here? Well, let me show you. I'm going to cover this up because you got to think about one term at a time. Let's start here. Can you simplify 2 root 20? Okay, 2 root 20 is the same thing as 2. Can we factor 20? That's the same thing as 4 times 5. This is a perfect square. This is a prime. We're good. So we look for our perfect squares. Take the square root out. 2 times 2 is 4. What's left on the inside is root 5. I'm going to write it up right here above it. 4 root 5. Now we look at the second term. I'm going to take it over to the side. We've got 3 root 45. Okay, I'm going to rewrite it in terms of perfect squares and primes. 45 is 5 times 9. Do you see a perfect square? Right there? So let's go for it. Perfect square. Take the square root out. That becomes 3 times 3, which is 9. We got 1 3 from here, times the square root that came out. 9 root 5. Let's put this one here. 9 root 5. Next, get rid of this term. We'll uncover this term. Let's start with, I'll do this one over here. Square root of 180. Okay, 180 is the same thing as 18 times 10, right? Okay, that's not perfect squares and primes. Let's go a little deeper. How can I rewrite 18? 18 is the same thing as 2 times 9. That's a prime. That's a perfect square. I can rewrite 10 as 2 times 5, right? Okay, let's look for our perfect squares. I can see 2 of them. One's obvious. Here's the first. Take the square root of 9 on the outside. You end up with 3. Where's the other perfect square? It's kind of hidden here. I've got 2 times 2. 2 times 2 is 2 squared. Take the square root, take it out. That's 2 times 3 on the outside. What's left on the inside? Just 5. So we have 6 root 5. Write that up here. Now add them all up together. 4 plus 9 is 13. 13 plus 6 is 19. I have 19 root 5. All right, that is about how much time I have. Here's the closure. So let's just do this one real quick. We've already got a root 3. Can that be simplified? No. Here's another root 3. That can't be simplified either. So those are definitely like terms already. Those are like terms. What about this root 28? That's not a like term, but it might. I think we can simplify that one. Root 28 is the same thing as 7 times 4. Prime perfect square. let's take the square root of that perfect square out of the radical